Well, thanks for having me here at my first Polar Data Forum. I'd like to begin by acknowledging the Muhunina people here on Lucieer as the traditional owners of the land that we're meeting today, and pay my respects to their elders past and present. I stand with them for a future that respects self-determination and treaty. My name is Vanessa Lucieer. I'm a researcher at the Institute for Marine and Antarctic Studies, which is a research institute of the University of Tasmania, and our building is just next door here, next to CSIRO. And I'm going to talk to you today about Seamap Antarctica, which is a new initiative yet to be launched, not till February next year, which basically uses the architecture of our current national seafloor mapping program, Seamap Australia, to start to bring a lot of the Antarctic data together for use for management within Antarctica. So over the last couple of years, we've seen the recent advances of mapping, of imaging, of all types of data regarding the collection of data in previously unknown regions of the Antarctic seafloor. Our international collaborations are increasing with these new technologies, and we're starting to generate, as you know, vast volumes of bathymetry, of benthic imagery, and of ecological data. And the need of having to bring this all together into one data platform is probably, really timely. Yet these data sets still exist in scattered institutions. Access to them is really difficult in some cases with projections, with different data formats. Data sits within different disciplines, and it limits our ability to collect and value this information to really be able to hit at where we need to get the impact to be able to increase our funding to be able to collect more of this data and understand Antarctica. So with climate and human pressures intensifying and the need to integrate this into a single discoverable platform, I guess it's more urgent than ever. So our aim was with Seamap Antarctica is to deliver a unified, accessible and standardised view of starting with Antarctic seafloor habitats and bringing into it other environmental data to transform this fragmented data into a powerful resource for science, policy and conservation. We've talked a lot yesterday about who our intended audiences are. Now with this product, part of this intended audience is also to work with people who are not familiar with GIS platforms or remote sensing technology, dealing with managers who want to be able to access that data rapidly and be able to visualise it in a portal where they can bring all that data together. So this is an Australian-led initiative. It's actually being funded by the Australian Centre for Excellence in Antarctic Science to integrate and interpret this Antarctic seafloor data primarily. The Australian Centre for Excellence in Antarctic Science was an Australian Research Council initiative that's run for the last 5 years, and this platform has been funded as one of the legacy projects to be able to bring all the collection of that data generated over the last 5 years into one portal moving forward. This is deliver it into aggregating our geomorphology, our bathymetry, ecological and imagery datasets into this standardised and open framework. To deliver habitat mapping to the Australian or the Antarctic Treaty System and to CCAMLR jurisdictions. So as I said, part of that target audience is to work with managers that are not familiar necessarily with downloading and working within a GIS environment. So we're building on the investment of Seamap Australia, which is our national portal and has been recognised, which was launched in 2017 and recognised in 2021 as the Department of Environment premier platform for being able to deliver seafloor information as a trusted data set. And this should allow us to enable data sharing quite quickly and our interoperability with our Antarctic collaborators and other Antarctic platforms. So the purpose of being able to build from the Seamap Australia Foundation is really to derive how we look at marine spatial planning, at looking at vulnerability assessments and at conservation. We bring into this Squiddle Plus, and some of you may have heard of Squiddle. This is also a national imaging platform for hosting, classifying and delivering seafloor data from around Australia and now the Antarctic. And it allows us to be able to explore that data in real time and link back to the Squiddle databases. This should transform our ability to provide rapid information and evidence for informed decision making. So this project's been running for, it started in January this year. So at the moment we're hosting around or presenting around 180 data layers, and that's growing daily, ready for our launch in February next year. All the data is aligned into the Antarctic polar stereographic projection. So just a little bit of information about how the data platform actually works. We are using a federated data model to be able to access and share this data. This means that the data actually sits with its original owners, and to the user of Seamap Antarctica, it looks like it's a unified platform that's delivering from this one space. Each institution keeps its own datasets within its own infrastructure, using its own common standards and vocabularies. Within Seamap Australia, we do a similar thing where that data sits in a federated data model, and then each Sunday night at midnight, we do a scope and a search, and we identify any new data that may have been brought up for seafloor mapping from around the nation. Then that data is classified into a consistent vocabulary. We haven't yet progressed to that stage yet in this first 10 months at looking at consistent classifications for the seafloor of Antarctica. The first part is to start harvesting and identifying that data to see how we can bring it together. We use shared metadata standards, persistent IDs, and these interoperable APIs, which allow for authentication and authorization of that data. And it means that when we harvest, that's all synced with the metadata and doesn't include the raw data. We respect data sovereignty and the diverse policies. This reduces duplication and also scales across our jurisdictions, allowing updates to flow from the users where they are sitting with their data in real time through to Seamap Antarctica so that we don't end up with dated datasets. I guess this requires a fair bit of complex coordination, and this is what sits in the back of our architecture. And the dependence really is upon the performance of an update of our partners in being able to deliver that data. And this does require strong governance, that people host their data appropriately and that they have standards within their metadata that are compliant. So I'm just going to give you a little bit of a tour of what Seamap Antarctica looks like. So this is the platform. The platform takes the same interface as Seamap Australia, where we start with the catalogue at the top, and we can see that we've got multiple different categories here. So to start with our categories, we've got our aerial imagery, we have our biological datasets, our geological datasets, our human dimension datasets, some information on ice dynamics, and I was interested in the previous talk from ESA to see that there might be some new information that we can pull across from there, our terrain datasets, and boundaries and points of interest. Now, within each of these categories, we can extend these out. So the example for biology is that we can look at bioregionalisation, at ecosystem data, habitat suitability data, some of the seafloor imagery, and species occurrence and distribution. So once you select a layer, say we look at species distributions here, now we load up the information and it shows us here the regions of common profile for the Kerguelen Plateau. You will see up the top that on the left, it then takes from the catalogue across to the active layers, and it loads that active layers up with being able to show you the legend for that information. As I said before, we're just presenting this information. So if you were to click on the information button next to the title of the information there, it'll tell you something about what this data is actually about. And then it will show you what the API access is, and so that then you can go and connect to the web mapping service to be able to connect that to your GIS if that's information that you would like then to download and do more sophisticated analyses with. But in this first instance, many of you that's probably worked with Antarctic data, there's multiple projections, multiple transformations, and you can spend actually many days just downloading the data and trying to coordinate it all into the same projection to actually see whether it's the data you want to be able to do your analysis with. So we're hoping that this rapidly moves you across that process to be able to visualise the information so that you can make those selections for linking to your web mapping service data. We can also provide alternate views to the legend here. So if the data is published in a paper with the appropriate metadata, we can also select multiple alternate views. And so in this example here, not only are we showing the classification of the regions of common profile for these species, we can actually look at the uncertainty estimates of looking at the probabilities of those classes. You can then click on an individual grid cell, which will provide these map pop-ups that allow us to query the data and dynamically render the data summaries to configured templates. So here we're looking at the regions of common profile, and it will show you what species that best represents across this with our probability estimates. So being able to visualise not just the data sets but the uncertainty that sits with that data transcribed visually from the metadata and from the manuscripts is actually quite useful. In this example here, a manager might like to load up the cold water coral distribution and probability. They then might want to look at the relationship of that to CCAMLR sites, protected areas, but also look at the areas of vulnerable marine ecosystems within an area to be able to help with reviewing proposals, perhaps for collecting further data, to be able to rapidly assess, well, are these regions close by some of these other areas without having to be GIS savvy and literate. In this example here then, we are then able to look at all the different risk assessments with that information and how that's presented over time. So down the bottom there, we are also able to look at this data in terms of future forecasting. So we can say, well, this is the cold water coral species prediction distributions, but what does it look like for 2027 and what does it look like for 2050? And how does this actually start to then harvest some of the historical data and future forecasting into the visualisation product? As we discussed yesterday, with search engines, we've been able to design searching by catalogue. You can also search by category, you can search by organisation, and you can search by layers by their titles and keywords. And so when you use the search functionality there, it'll actually, when you type in the word, say whale, it'll bring up all the keywords that indicate through there. So you're able to access the catalogues quite rapidly. When we show information like this, we can also, such as the geomorphology of around Antarctica, we can also use filters that allow for rich functionality associated with each of the layers. So here we can filter by multiple attributes, allowing rich exploration of the data as well, which again allows for that rapid access. Here we can combine layers to configure different map views. At the top here, you'll see under the probability, there's a little slider button that allows us to adjust the opacity of each of the layers so that we can create really nice visualizations of that data within this interface. You drag and drop the layers above to configure what's shown, just like you do in a GIS. And you can export these configured map views in high resolution. So here it shows here that you can export these as a PDF. It'll take in the legend and produce a really nice map view for you. The other thing that we can do is also bookmark. So you can take this scene and then click on that little icon there, and it will export a URL so that you can share these then with your colleagues. So when they open that, it actually configures all the data sets that you're actually looking at so that you can do this rapid sharing of information. It's also really important for being able to share with your colleagues, but for using in your reporting to sort of say, well, this is currently what exists for that site. We have integration with other sources with data that doesn't need to be locally hosted because those web mapping services already exist. And this example here is from the Integrated Marine Observing System, Underwater Marine Imagery. So the IMOS UMI Squiddle Plus facility. The plus stands for the integration of AI into being able to automatically classify these images and bring those classifications of that information into Seamap Australia. So this example here shows different locations where video transects have been run. That links then through to Squiddle. It then takes you to the Squiddle interface, and then you can move through the georeferenced images and the classified images of each location of this actually within the interface of the map. Again, this allows for rapid assessment of where that data is available and that you can explore it quite quickly. It allows us also to tell stories with the data, to explore derived products that can be optimised for a user-friendly mapping experience and can also be understood by non-expert audiences. And in this example here, we're developing under the featured maps at the top, a little bit like what we saw yesterday with the story maps, to be able to take people through a story of the data, to be able to look at the generation of maps, for example, for policymakers over time. So what's next? The project finishes in February with the launch. We'll be continuing to expand our data coverage and harvesting. We're hoping at this point, by presenting at this Polar Data Forum, we can bring it to the national and international attention for developing partnerships. We look forward to collaborating and co-developing new applications and new visualisation ways of bringing this data to the public. How you can contribute? You can contribute by making your data open, making it fair, making it well described with metadata that links to your publications. And this allows your data to be fully citable and linked to the original source. We hope that we can provide a platform that boosts the visibility and the impact of your research. So together we can make these really important stories for the Antarctic seafloor. So this week we received the first proofs of our website, which will be the interface that then hosts this mapping portal. So I'm probably preaching to the wrong audience here, but this is not just a map, it's a platform to be able to unify our knowledge, to catalyse our research, to really hit those impact goals and to guide stewardship of this Antarctic space. We really hope that we can encourage users to explore and contribute to Seamap Antarctica for the benefit of both Antarctic science and policy. I'd just like to acknowledge our multiple collaborators here, and if anyone has any questions about Seamap Antarctica or about Squiddle, please get in touch. Thank you.
All right, yes, two questions. I'm going to start with the right and then I'll move left.
Is this working? Yeah. Yeah, thank you so much for your interesting presentation. With my project, I'm also trying to achieve a similar federated metadata or data system. And we are running into issues with collaboration and imposing standards from the top down. So I'm just wondering, how did you achieve something beautiful like this? How do you make sure that even though people or partner organizations that help or contribute to such a platform are adhering to those standards you impose on them from the top down, kind of?
Sorry, I'll move back to the microphone. Well, I guess at the moment, as I said, we've harvested or brought in 182. A lot of those are either from our partners at the Australian Antarctica Division or Antarctic Sciences New Zealand. And so we haven't yet, I guess, broached the difficult data. Most of this is what is already open and searchable, and the data sets that have come from the Australian Centre for Excellence in Antarctic Science. So perhaps ask me in about March when we sort of start to get to the gnarly end, because the first bit is to try and get a lot of the data that's really easy to find and easy to host. We have had a lot of challenges with the projection issue, as you can appreciate, and trying to bring that in on the fly and translate. But yeah, certainly within a lot of the data that we're working with at the moment that's collected under current programs, there are standards that are already applied from the research grants and from the funding that suggest that the data needs to be at a particular standard when it's released. So it's part of the I guess, the contracting. So we're able to sort of influence from that side. But as we get through into historical data, I suspect we're going to come up against the problems that you suggest.
Thank you. And maybe, could I ask another question just now, or Jonathan? Could I ask another question just now, or?
We don't have much time.
Okay, yeah. Thank you.
Just very quickly, we'll pass over to Taco.
Vanessa, thank you. Very impressive work. How do you coordinate with Seamap?
So a lot of the data that comes through on SUSE that show, like, you can visualize some of those individual data sets. This allows us to bring it into, we connect to SUSE, so some of that data is actually SUSE data, but it allows us to bring it into the one interface so that we can overlap that information to be able to analyse that data. So the interface itself is a little bit different to Seamap. But as I said, the data still sits with SUSE. We're just visualising it with all the other data that's available within the community.